Alright, this one's not even that bad. Consider the function. It's a quotient, so we got to use the quotient rule. X is bigger than 0. Determine the n in terms of n, so meaning n is going to be in your answer. The value of x for which the derivative equals 0. So first we got to take the derivative. So we got f prime of x equals low, n is just a number, d high, that's 1 over x, minus high ln of x, d low. So the derivative of x to the n, that's just power rule. You bring that out front and you subtract 1. So it's n times x to the n minus 1 all over low squared. So we have x to the 2, well, I'll write it like this, x to the n quantity squared. That's the same thing as x to the 2n, right? Because you, if you have a power of powers, you multiply the exponents. Anyway, that doesn't matter. We're going to simplify and set it equal to 0. So something that I want to mention then is the x to the n over x. Remember, that has like an exponent of 1, and when you're dividing, you subtract the exponents. So this division here is actually the same as, well, n minus 1. Right? So this is actually x to the n minus 1 because I have an x to the n over an x to the 1 and I subtract the exponents. So that's how I simplify that part, and that's good because I have an x to the n minus 1. It's like it was supposed to be like that. And then I have n x to the n minus 1 times the natural log of x all over x to the 2n. It's going to turn out that that actually doesn't matter right there. So I simplified a little bit. Now I'm setting equal to 0, and I'm going to solve. So I multiply both sides by x to the 2n, and that will go away. That's what I meant, but it doesn't really matter, because that goes away. Anything times 0 is still 0. Remember, fractions only are 0 when the numerator is 0. So we have x to the n minus 1. I'm actually going to factor that out. So it's times 1 minus n ln of x. So I have this. Right? Because if I multiply this back in, I get x to the n minus 1 minus n times x to the n minus 1 times the natural log of x. So I have all of that. By the zero product property, I can set each piece equal to 0. So I'll set that equal to 0, and I'll have 1 minus n ln of x equal to 0. Now, from the original problem, it says that x is greater than 0, meaning that can't ever be, because we, like take the n minus 1 root of both sides. I mean, like say it's 37. If we take the 37th root of 0, it's still just 0. So x cannot equal 0. That means we can ignore that part. So on this, I'm going to add n ln of x to both sides. And what I get? Well, I have n ln of x. And I'm trying to solve for x, so I'm going to get the natural log of x by itself. So I'll divide by n. And I have the natural log of x equals 1 over n. And remember, anytime you're solving natural log equations, you exponentiate both sides. So I'll say e to the ln of x equals e to the 1 over n, and then there's a property of logarithms that say the e and the ln cancel out because the ln is actually a base, a base of, or it's like log base e of x. That's the same thing there. So those would cancel out. So that's why the natural log goes away, and I just have x equals e to the 1 over n. And that's pretty much it. 4-minute video. I gotta get back to my meeting. Good day, sir.